All right, we are now recording. So let's actually start with like questions. So do we want to like, let's, for those that are here, do you want to go over like the mates first and then ask questions afterwards? Or do we want to go through like any like initial questions first?
I would say the mates first.
All right. So
Okay
the
then.
first part about mating is primarily you got to insert the parts. So right here, we've got all of our parts in the relationship that they're in the part studio. So as we can see right here, that's actually, I'm just going to click a random spot real quick. So right here, I'm not sure if I can annotate my own screen, but for those that are watching, over on the right, we can actually see these three arrows, which means that it has degrees of freedom. So this is actually quite important. I just deleted it. So right here, we've got a part. We're going to call this part 2. So because this is not connected to anything, I can drag it around however I feel is best. So what a mate is a mate is something, so this part is fully defined. What a mate will do is it'll make this part right here connected to this part right here in some way that we decide is important. So to bring up mates, we press M. Now there's a lot of different mates, but the most simple one is fasten, which is where we remove the degrees of freedom from everything and we attach these parts right here. So let's attach the parts. So I find the hole, I click the hole, and I click this edge, and it snaps together. Now, the important bit when we're doing things like this is you see right here, I'm actually going to zoom in so for a better view. Right here, let's move this out of the way. The holes don't line up. So the first thing that we can do in this situation is press solve, but that doesn't work. So the more important bit about fastening is that fastening, when we do it, it removes all of the degrees of freedom. So this will be attached to this. Now, if you notice, there's that little bar there. So I'm actually going to stop right here. Saeed, do you see the colors that are like the circle?
Yeah, the X, Y, and Z.
Yeah. Just like, can you make an educated guess on like what it means to have the like two things overlap? I've said it like a couple times.
Like when you use the fastened?
Yeah.
Well, initially, won't they like stick together?
Yeah. So
And
no, keep going.
oh, that's it. I would say that they would stick together, and the X, Y, and Z axis will be just both set to the same thing.
So right now I can still move this around. This part isn't connected to anything, but just like you mentioned, these are all gonna move around. You know, it's one thing now. So let's say we can also mate with fasten to points. So I'm gonna select this part and select this part. Now, someone's dog is very excited.
Yes, that's me. I am very sorry.
It's fine.
Steve is a character, let's just say.
But right now what we see is, you may notice, are these two parts were just connected, right?
Mm-hmm.
But now only this one is moved. That causes us some problems. So the thing about that is this Onshape is a very smart program, but it doesn't need to show us everything that we do in the mating process. So it moves one thing and just calls it a day. What we can do to fix that is click solve. Solve means it'll show the whole. I'm actually going to turn my camera on just real quick. I think that'll work. Solve means that it'll load everything into Or will it? It'll be mad. Never mind. Because I'm also recording. Oh well. So what it'll do is it'll push everything into the final thing. It'll solve the assembly to say. Does that make any sense?
Yeah.
So the other thing about mates that is extremely important is you have to click that green check mark. Without the green check mark, it'll look right, but if you were to say close it, so let's go back. Let me do the process again. And I click out of this, I just click the red X. Pops right back to where it was. So you have to click that green check mark right at the end. I think there's been some excitement outside. So, can someone, maybe Vincent or Renan, tell me, like, what are these arrows down here? What are they?
Of course. So one of them will flip your primary axis, and what that means is when you click it, basically the entire piece will, it'll reorient like that. If you could escape out, yeah. So if it was pointed up one way, it'll point down the opposite way. And then the other one is the axis of rotation, which will basically ideally flip it 90 degrees in any direction in a more horizontal sense and not flip it vertically, if you will.
Yeah.
So that's what that's for. It very much rotates it into position.
Yeah, think about the primary axis as flipping and the secondary axis as rotating.
You use these terms primary
for the most part.
You use these terms primary and secondary axis. What do they mean? Like, what's the primary axis that I should be looking at?
The primary axis right now is, well, judging by the square in the top right, it should be, it'll flip you along the z-axis one way or the other. It'll basically do technically it'll do a full rotation around the x-axis if you look at it from the left plane. So if you want to think about it like that.
But yeah, the primary axis is, in general, what you connect to. So in this case, I'm mating to this origin point right here. If it were to attach directly onto something, it would attach right onto it. All right, so we're gonna X out of this mate. But actually, no, let's not. Let's go back. Go back. No, go forward. All right. So the other thing is remembering this degree of freedom. Now this entire structure has no degrees of freedom. It's been fastened to that origin point. I can't move it, which means that for many cases this is a completely, it's not free floating anymore. It's the more important bit. So we can tell, however, I got part 3 down here that's still moving around. So that's not a fasten, and that's why it still has that. So let's now backing out of this. We've got several other types of mates. So again, bringing up that mate tool. There's also other ones. Now, in full honesty, most of these are some of these are more specialized than others. In general, you'll use fastened a lot, you'll use cylindrical a lot, planar a lot. It all depends on your structure, but there are, ways to do things. One of the more important ones that we use is called a slider mate, which is one of the ones that allows you to continue to have different degrees of freedom. So, going back to where we were, we're going to attach this outside edge, so this edge of the circle, to this edge of the circle. Does that make sense? Let's back out. So what a slider mate is, if we look at it, I can move this up and I can move this down. But notice how right here, we're going to isolate. We're just going to quickly mate this so it removes its degree of freedom. So right here, this can move up and it can move down, but it cannot move side to side. So I can move it up in a slider mate. I can move it down in a slider mate, but I cannot move it side to side. So, any ideas how we might use this?
Pistons.
Well, Saeed, any ideas of why we might use like a slider mate?
We can use it for like a specific a frame or an object that we need to, use the sliding mate. I'm not sure like what kind.
So
different things.
A piston is the primary one, but think about things that
Think
might.
about something that we had on the 2022 robot that included things sliding up and out, if you've seen it.
Oh, not the pistons, but the shooter. It had like materials on the side of it, and it could like go out and in.
So the shooters are run by pistons. Think about like on the very sides of the robot. Like what went up? So think about this. We need to design something that needs to go from here to this, from this height configuration to this height configuration. So like it was the, I'm not sure if you recall, but it was the main thing our robot last year was designed to do.
An extender, like.
Yeah.
Yes.
So what we're looking at specifically, is called the climber, but anything in.
Yeah. He doesn't know what we called all that stuff. You're gonna have to. You're trying to get him to describe something, but we all have names for it, right? So give him some choices,
right,
or something. You know what I mean? It's like there's a little bit of a shorthand there if you start talking about it. So,
but an extender is what we called the climber. Well, the climber is extending, but you're completely correct. It's like it's anything that's moving in one direction. So in this case, last year was the climber, but an extender or a piston is generally the most way to do it. However, I'd like to ask another question, if I may. Is this necessarily possible? Like to have this square just intersect with this hole really nicely? Just like all the way in?
No.
I don't think physics agrees.
I mean, Einstein says everything is relative, right?
Theoretically, a photon can phase through a sheet of paper, so of course anything is possible.
So
theoretically, Vincent, let's go with no.
Yes, but you're not going to put time into this, so okay.
The main thing about
stick
this
to Newtonian physics.
So a slider is one of the special mates. Well, all of them are special in that they can include things like offsets, which is where we can change how we offset things. So in this case, I can change how closely these two things are related. So this to this is 1 inch, so it's a 1 inch offset over to the, in this case, the left. So when I type in numbers, I can bring this over, and still I can move it up and down, but I cannot move it side to side, even though this is now outside of the original tube. So the same function, pretty much that's how offsets work in almost every mates. The other thing that we have are limits. Limits for these are actually extremely important for sliders because although we would like a piston to extend however far we want, not all of them do. So we have minimums and maximums these can move. So as you can see right here, it'll give us a data reading on how far it's gone. In this case, 4.265 inches. So we can set the compression to be a minimum. Let's set it at 0. And its minimum movement is 0. So it can't move any more this way. It's fully extended. However, we can also set a maximum. Let's call it 2 inches. And now it'll move between 0 and 2 inches. But no matter how far we move it, it'll never go beyond that amount, which is extremely important when we're trying to figure out how far we want things to be spaced out. So, does that make sense, Saeed? And anyone else that's not really had a lot of chance to play with slider mates before?
Yeah.
Yeah, also what I want to say about limits is it's important for if you have multiple parts that are rotating off of each other, they're rotating in relation to each other, like say our intake design, it has multiple arms that rotate off of each other. And so having that so it can just do a full 360-degree rotation through the robot in the CAD model, it's useful for stuff like that. If that makes sense, sort of?
Kinda, yeah.
All right.
Renone's just basically
gonna-
talking about things rotating in relation to one another.
I'm going to chime in on that. You're right, Renone, but the way the geometry of the intake is set up and the way the model is set up, the rotation is limited by the piston slider mate, which is inside the piston in the model. And the rotation of the arms in the intake are actually correctly tied to the translational distance inside the pistons themselves, because the model is actually set up that way. So you can actually get the correct. So your rotational limits are actually being driven by linear limits somewhere else in the mechanism.
Speaking of how mates can be done, like how mates relate to each other, fasten mates and slider mates are also important. So mates combine off of each other. So let's just quickly fasten this, like we discussed earlier. All of the degrees of rotation for this one are connected to the movement of this piece. However, oh, come on, is it being uncooperative? Oh, because I can only go up. So when we move this slider mate, we can see that even though this is fastened, which decreases its degrees of movement, it moves with our slider mates. So this mate, this fastened 2 mate right here, depends on the slider 1 mate. So just because you attach something that's locked in place using a fasten mate, you have to be wary of how mates relate to each other. So just like they mentioned before, rotational mates can depend on slider mates, fasten mates can depend on everything else. Mates are a lot like designing and how things can be dimensioned off of each other. Things can be mated to each other. So it's incredibly important that you look at this for more than 2 seconds. The other thing about mating and having things be attached is if we were to imagine, say, that this was a piston, this movement, if I were to take my hand and push up, the movement of this hand, only moves in the same direction as my piston. So mates depend on each other is kind of the statement there. So does that kind of make sense?
Yeah.
All right. So let's actually back out of all of these mates. So again, going back to that full degrees of movement. Now, you may notice that this piece has a rather circle-shaped hole. Wouldn't you say?
Yes,
Yeah.
Chad, I would certainly say that.
All right. So bringing up our mate tool again. So we've done slider. This is a cylindrical mate. This is really important, and it's really important when we use circles. So as you can see, so cylindrical, just to kind of make sure the vocabulary is all clear. Cylindrical is just a circle, tube, another circle. It connects cylinders together, and so it connects. It's really good at connecting circles to circles and things like that. So, again, it functions a lot like a fastened mate. However, you may notice something is a little different than a fastened mate. Can anyone make an educated guess of why?
And this is cylindrical?
Well, yes, it's a different kind of mate, but why? What's different about this mate compared to a fastened mate?
You mean a slider mate?
No, well, yeah, any other mate, but this is different. How?
It allows for 2 degrees of freedom.
Can you? So, Renan, what kind of degrees of freedom?
It can rotate along the point which it's fastened, or it can rotate along the axis which it's fastened, and it can also slide along that axis.
So, like
or
this?
the y-axis which it's fastened to. Yeah.
And that's different than a fastened mate in that it can, yeah, just like he said. So it can rotate around. So as you can see in my kind of shaky hands, it can slowly spin in circles while also being able to move up and down. But very similar to a slider mate, it can't move left or right. And because this isn't fixed, the whole thing is moving with it. All right? Does that make sense?
Yep.
Yes.
Yep.
Yeah. Also, I should say, in case you want to do ball mate, I added the pieces we needed for that.
In total honesty, I personally, my mating has always been a lot of fastened. That's more of a me thing.
I mean, fastened is the mate you'll use the most, but
yeah. Now, Vincent, do you mind explaining what a revolute mate is and how I might use it based on something that I've got right here? Because I don't know. I looked it up, but only so much, unfortunately.
A revolute mate is, well, the main idea is that it's very similar to fastened, except it allows for 1 key degree of freedom, which is that it can spin around the axis that you apply the mate to. So, for example, I'm going to make a revolute mate for this light blue piece into the indented hole in the dark blue piece.
All right. Actually, do you mind
what
if
this will do is that you still can't move it up and down, and if you try to do it, it'll move the entire thing. But what you can do is you can take this piece and you can spin it around like that.
Well, I'm afraid I can't quite see it moving, but there we go. Because it's delayed.
Because it's your screen.
Yeah.
But yeah, it can move like that.
So why would I use this instead of, say, that cylindrical mate or something else?
Well, sometimes you don't always want something that's spinning to be sliding around. You need it to stay in one location, but you need it to spin on something else. So, like last year, if you
let's move away from last year. Let's focus on something. Let's be a bit more general. So if I don't need this to move, but I still need it to spin,
here,
would that be something
like a pinwheel? Let's say you don't want a pinwheel to be sliding on the axis it's spinning on, but you still want it to spin. So
if
a
I
pinwheel, you would apply something to the axis and it would spin around it.
so could I use this in like a motor? If I
In a
was
motor, you mean for like designing a motor?
well, not designing a motor, but like say I've got myself an attachment and I want to attach it to some thread. I've got a circle on the motor and I want to attach it to the circle on the motor. And I've got this, I want it to be fastened, end to end. But I want it to continue to spin because, I'm driving like a gear or I'm driving like a chain or something like that. Would I use something like this?
I'm not entirely sure what you're
I would like
suggesting.
All right. So, I've got something like I have a motor with a gear on it. And next to it I
Yes.
have a shaft. And the shaft has got a shaft collar and everything else on it to keep it in place. I want to attach a gear to this shaft. I want the gear to be able to spin, even though the shaft is just stationary. And then I want the gear to still be able to spin. Would I use something like this if I can, just place it on the shaft?
No, because, well, first of all, most of the time you won't have to do that because we like to use hex shafts a lot. And I mean, you can't spin on hex stuff for obvious reasons because there are too many edges and you just get caught on it.
Mm-hmm.
What we like to do is we make the entire shafts rotate with bearings, and then we would use a fasten mate to stick a gear onto it. So the gear spins, or the shaft spins, and it takes the gear with it. The gear cannot spin while the shaft remains stationary. So you want the shaft to spin and it to take the gear with it while it is spinning.
All right. So that's one of the main points of cylindrical mates that I recall. So in general team usage, cylindrical mates are really, they're something that we pull out only for special occasions. They are useful in the sense that you can have, direct connection and still be able to rotate. But there are other ways that can do it that often, when we're putting them in practice, end up being a bit more efficient. So although Revolute mates are very good at what they do, there's often better ways to describe them in CAD. So moving on to the next mate, we've got pin slot. This one is the... Oh wait, can people still hear me? Because
We can still hear you.
all right.
Yep, we're good.
So, a pin slot, if anyone has ever seen or maybe driven or like even seen in a video game, moving something from one edge to the back. So think of it like a lever. You want the lever to be able to go all the way from one end to the other without having anything in its way, but you also don't really want it to be able to push all the way through something or all the way in the back. So what a pin is the pin is the actual thing that's moving. And, a slot is that linear motion that it can go through. So in this case, we've got a very nice pin here. So we select the pin, and we can select a slot. So what pin slot will do is very much like slider. This can move back and forth. And again, it can't move side to side, but it can go all the way back and forth. Would anyone like to take a guess on why we wouldn't just use a slider for this?
Because a slider would make the range of motion vertical along the z-axis instead of horizontal along the x-axis.
Can you repeat that one more time? I'm afraid I didn't quite hear it.
No problem. Using a slider would make the motion vertical up and down along the z-axis instead of horizontal side to side along the x-axis, which is the purpose of a pin slot mate.
So I can't move this up and down any, but I can move it forward and back. Is that quite just to make sure that we're all referring to the same thing? Because X, Y, and Z do change based on your mates.
Well, ideally, not ideally, but yes, that is what I'm saying.
All right. So yeah, a pin slot is kind of like a more specialized version of slider. It's also another mate that you will most likely not use much, if any. I don't think I've ever used it other than training. Has anyone else here used it any?
I
At
mean,
Riverside once.
I used it. There was while we were coming up with ideas for a problem that wasn't actually a problem for the climber hooks last year. I made like a prototype concept idea for something that could help. It involved a pin slot mate.
Interesting. Yeah, to be perfectly honest, I don't think I've ever used that outside of training. And then mate, planer. Renan, do you want to maybe explain planer? Or maybe Vincent? Because this is also another mate that I personally don't use much.
I'm cool with taking planer. If you want to do it, Renault, you can take it.
Seeing as I don't have Onshape open right now, and I'm assuming you do? Yeah, you
Yeah.
do. So
Okay, then.
probably you. Sorry.
I'll take planer. So what planer does is you attach a point. So it's basically you set it up like any
Here,
other
Vincent,
mate.
probably you should share your screen for this, right? Or I
Or
don't know.
just
do
explain it
whatever.
to me and I'll do it because it shows up better on the recording. Or I'll just
Okay.
edit this and it'll be cool.
Yes, with that crisp NCSSM Wi-Fi, gonna share very well.
So okay, this is going to be kind of hard to talk about from here, but okay. So if you can see, I've now basically applied the mate so that the blue pin piece is on the surface of the dark blue piece. And what this planar mate will allow me to do is the plane of the surface that it's on, so that face, essentially, you can move the pin piece horizontally on. So I'm going to make some movements so you guys can see that.
Mm-hmm.
Yeah.
It can move horizontally on that. And because limits aren't set, it can even go off the piece horizontally, but while still staying restrained to the plane. Now, does anyone know? I keep talking about being restrained to this plane, and that implies that it can't move some places. What are the places that you guys think it cannot move?
Well, it can't move up and down.
Yes, that's exactly right.
Mm-hmm.
If I try to move it up, the entire
Along
piece goes up.
the
If I try to move it down,
is that Z-axis that it can't move along? I can't see very well from
It's
this angle.
currently the z-axis, although the axes can change. So to simplify the vocabulary, this edge and this edge right here. So this edge on the top of the plate and this edge at the bottom of the T piston thing are connected. They cannot move from each other.
Yeah, well, not the plane itself, not just the surface, because we haven't set any limits yet.
So,
But that is
Okay.
basic. That is the idea. So if you try to move it up or down, the blue piece won't come flying off the surface. It'll just go with it because it's stuck and it's restrained to that plane. And if you wanted to add some limits to restrict its motion, you can do that too. That's really helpful because, like I said, you can fling it off the surface and it still lets you do that. And if you don't want it to do that, you can always go in and limit it. And say, let me see. It's going to be hard to.
I've got the limits things up. So one of them is the one limit
Okay,
here.
you do the limits.
So it's right here. What it's just saying is this X can only move 1 inch. So yeah, I can. Oh, it's moving the whole thing. I need to move just this one piece. So the Z can rotate. It's being a little goofy, but don't know why. It can rotate, but this can only move but so I think it's being confused because two people are editing it at the same time. But
my hands are off the screen right now, so you have full reign.
But right here, it can only move, the top piece can only move between 1 and 4 inches. So as long as it stays on the same plane, it can, be within this value. Does that make sense, Saeed? I just want to make sure that we're not accidentally moving too fast.
Yeah.
If you've got questions, please just stop us, because I'm more concerned about we've gone through pretty much all. So we've gotten through. I just want to make sure that you understand the concept.
Well, yeah. So mates will have like a specific purpose, like cylindrils, to either move off the X, Y, or Z axis, and some whether move off of the horizontal axis and the vertical axis, or just one of them by themselves.
Yeah.
Am I correct?
Yeah. So
Yes.
all mates in some fashion.
I do have to go right now.
Oh, that's okay, man.
I will see you guys on Thursday.
See you there. Well,
right.
I won't be there.
Wait.
I won't be here.
I might be there Thursday because my game got canceled because of a hurricane.
Well, NCSSM might also get canceled because of a hurricane.
No. NCSSM has not been canceled on Thursday. It has not been canceled on Thursday.
Yet.
The building, I mean. Yeah.
Anyways.
Okay, see you guys.
But yeah, all mates in some form or fashion restrict a mode of freedom. So pretty much fastened mates restrict all of them. Sliders, you just restrict some, but you can still move. Cylindrils, you attach everything, but it still rotates. Pin slot is very similar to sliders, although we use them in slightly different ways. Planers reduce, you can't move off of the plane, so the two things are always going to be attached. So you can still, move up, down, side to side, but you cannot move apart. Parallel is very similar to this planar function. Actually, I need to. Let's delete the planar.
Delete the planar.
It'd be helpful if I didn't have the parallel. So, again, separating them apart. See, we talked about parallel constraints when we did your design, right, Saeed? Also, am I pronouncing
I think so.
Am I pronouncing your name right? I just want to make sure that before.
Yeah. Yeah, you are. You're fine.
All right. I just that thought just came to me now, and I didn't want to be insensitive. So, parallel means that they're going to be, always in the same line, right? So, right now, it looks very similar to our planar mate, right?
Yeah.
So, I'm moving it off, except when I look at it from the side, let's just move this out of the way. Looks, oh boy. Let's get these straight on. Looks a little different now, doesn't it?
Yeah, it looks a little bit different.
How so?
Well, were they supposed to be apart?
Well, the last one, they were right on top of each other, right? But now they're not. So, in a planar mate, we can actually see. I'm going to bring this over to the side view because I actually accidentally made my job a lot easier. So, we see they're both at an angle, right?
Yeah.
So, what a parallel mate does is it doesn't restrict the motion of the actual object at all. So I can click on this. The problem is see when I'm rotating things?
Yeah.
Do they rotate to be the same degree?
Well, it looks like they're both rotating to the same degree.
Yeah. So pretty much what parallel will do is it'll make sure that things are rotating in the same way. So it doesn't restrict the motion of the object, but it changes how they can be aligned. So, pretty much...
Because of the way this is oriented, I'd call this example more aptly the perpendicular mate.
Well, no, because these faces and this face are parallel, right?
They are, but because of the way they're oriented, it definitely lines up different.
It's a little wonky, but that's okay. Not
I
everything.
mean, it depends on the face you originally chose, which means if you switch directions, it'll be
Yeah.
different. My dog is back.
So, do you think of anything where it might be important that the two things are moving at like they're all parallel? So, something's rotating that might be important that they all stay aligned.
The other face, like the other object.
Yeah, another so we've got two objects and they have to both turn to be at the same angle. So think you let me I'm going to try and see if I can have my video. But think about like think about like in a car, I turn the wheel. I turn the wheel. Do both of my tires go in the same direction or do I do something a little different?
Well, when you turn the steering wheel, the tires will move.
Yeah,
The front tires will move.
but do they
Well,
both
it
turn?
depends.
Well, let's simplify this. I've got like a very simple car. I turn the wheel left. Do both wheels go left, or does one wheel go left and one wheel go right?
Well, both of them go left.
Yeah. So parallel mates are very good when for things are like moving around, keeping them together. So because we use swerve drive, this isn't so much of a problem. But for other teams, you might have seen that use things like West Coast Drive that need to make sure everything is aligned and all parallel. This is a very, very helpful mate. Because when you turn left, unless you're doing it like a tank, you need to have both wheels turn left or or both wheels turn right. Because if one turns left and one turns right, what do you think happens in a car? If that were possible.
If that was possible, then the car would like go its own separate ways, or it would
Yes.
just keep going straight.
It would split like a sandwich, right? That's some Looney
Yeah.
Tunes type action.
But yeah, what I will say is that on this team, I don't think I have used not planar, parallel once, like outside of tutorials in my freshman year Riverside class,
And that's
and then other stuff. So this is definitely one of the least common ones, but nonetheless, it's good to know.
and I'd argue that the least common, as in the very, very, very lowest one is
The one that
ball.
I brought in specifically to
ball.
show.
Yeah. So as we can see here, we've got a very nice ball. So we press the ball, we press the inside of the cup, and then suddenly we've got a ball and a cup. So I'd like to I'm afraid this may not be working quite like how I assumed it would work. But yeah, this one, as you can see, let's just give it a better view. I want to rotate this, please. Makes nice kind of that hinge thing. Looks kind of like a swing, doesn't it? I haven't been on a swing in too long.
Dang.
But yeah, this works on all of the rotations, so that one.
Okay. Another thing I'd like to touch on, Chad, you've discussed a lot about limiting the degrees of freedom. What are these degrees of freedom you speak of?
So, going back, can you see the like different parts right here that I'm highlighting? See the circle with the lines and the triangles.
Yeah.
So a degree of freedom is the ability for each one of these things to be able to change. So right now, each
Will that be for the X, Y, and Z axis?
Yeah, that's precisely what it is. This is an X, Y, and Z right here. And then we can also, just clicking on the squares right here, just like for quickly like moving it around. And, you know, this one will control how high up it is. This one, so on and so forth. But you see the
So
circle?
how many? I was gonna say, how many degrees of freedom do you think there are?
360.
Um,
Well, 360 is the number of degrees. Which so
Oh,
I can see why you did that with degree of freedom.
mm-hmm.
But in reality, there are 6 degrees of freedom. Moving on the x-axis, moving on the y-axis, moving on the z-axis, and then rotating about the x-axis, rotating about the y-axis, and then rotating about the z-axis. So it's essentially saying you can move up, down, side one way, side the other way, and then rotate in 3 different directions.
that's actually pretty cool.
Yeah. The other thing is, this isn't particularly relevant. I actually did find that some people do use Onshape for animations, like how people use Desmos for animations. And if you want to see something really cool with having different kinds of mates, look that up. I don't recall any videos off the top of my head, but it's a very cool phenomenon. But yeah, there's 6 degrees of freedom. So we can move this way, we can move this way, we can move this way. I can spin this way, I can spin this way, or I can spin this way. So 3 movements and 3 spins is how I like to remember it. Now, do you get like that degree of freedom part? Because that helps like do the rest of the mates.
Yeah.
So, unfortunately, I do have to go in the relatively near future. So we're gonna go
Me as
over.
well.
So just as a quick review, does anyone want to remember what fasten mates are? So, all right.
It keeps it as it is, 0 degrees of freedom.
Yeah.
It's fixed.
Fastened completely attaches all the way. Nothing can move. That's the way it's gonna look. That's the way it is. You can't rotate it. You can't move any of the 3 degrees. None of the things. So a slider mate
It'll
is
move the horizontal axis.
yeah. So you can move back and forth. Sometimes you can move. Well, you can move on one axis is really the more correct way to say it. So you can move on one axis. You can set limits on how much you can rotate, and you can set limits on how much you can move along that axis, which is those two. So those two are the most important that we're going to be using on the team. There's cylindrical, which is similar to fastened, in that it locks how many faces? Not how many degrees of freedom.
6.
So yeah, it locks 5. You can still it attaches it completely. So
Cylindrical is 4.
4, yeah. It locks it down so that way it cannot move anymore. So it cannot move. However, it can still rotate about that face that's fastened. So you can spin along it. A revolute mate.
The revolute. Can it revolute only the x-axis?
Yeah. So that one. Well,
only the axis to which it is applied.
Yeah.
Whatever that axis may be.
So revolute and cylindrical are similar. They're very good for spinning. Pin slot is very similar to slider, but we use it for slightly different things. A planer is how would you describe planer?
I kind of forgot about like planer.
So a planer.
Isn't it?
No, go ahead.
Wait, sorry. Isn't planer like only you can only like rotate the x-axis and the y-axis?
So planar, you can move we'll do another planar really quickly. So, planar, you can move in two directions. You cannot move off of the face that you are attached to. So, right here, I can move off of the face, like I can move towards anything, but I cannot move up and off of the face. I'm still connected to the face. And I can also spin around, but this edge and this edge have to be on the same plane. So they have to be connected or at the same height level. Does that make...
All right.
And then
that makes more sense.
Yeah. And then parallel is very similar to that. How is it different though?
Parallel, it makes both of the sides that you selected even.
So yeah, they're always the two sides of the two planes that they're set are always going to be parallel. So you can actually still move in all of the degrees of freedom, but when you change one on one axis, it'll change the other. And then ball is special, and I don't like it.
Ball is the best, Chad.
I don't like it. I don't think we'll ever use it. Having said that,
it's how all of the joints in your body work.
I thought some of them were like not. I didn't think all of them were. I thought some of them were slightly different. Anyways, the other thing I'd like to show very quickly is inserting. We're going to insert this. No, I don't want to create a current document. Now, let me see if I can find the tool.
Oh, grouping them all together? Yeah,
Yes.
Ty showed me that one.
So what this mate is, the group mate, is especially important when you're bringing in things from part studios that say are pretty much just the assemblies without the mates. A group mate is kind of more special in the sense that it locks everything in relation to each other. So when I click this, all of this has suddenly become one large group. So, even though this looks like this has multiple degrees of freedom, it's moving the entire thing as one unit. Which makes our lives say if this was already connected to this, and this was connected to this, and this connected to this, because of how we design and use that top-down design principles. It makes our lives much simpler because we can just say, all of this is the same as in the part studio, and it's done. We don't have to worry about this connected to this connected to this. This is fastened to this is a pin slot mate, so on and so forth. Does that make... You said that you use it on your birdhouse, right?
Yeah, I think I have. And it was like, it makes it easier instead of, as you said, using all those other mates, right? Yeah.
Mm-hmm.
The other thing is that there are very, very, very good Onshape tutorials about this. All of them are like 30 minutes long. They'll be linked with this video. They're very, very helpful in understanding some of the weirder parts of mates. Limits are your friend. And I really recommend that you go out and learn those. I unfortunately do not have time to go. We did not have time to really delve into them in
yeah, it's fine.
Yeah. But
limits are something I would say that if you mess around enough with them, you can get a really good idea of what they do.
Yeah, but not all mates are created equally, as you may have heard that we mentioned.
Fasten, Slider, and Revolute are really the big ones for me.
Yeah, but it's good to know all of them in case you ever find yourself needing to use a ball joint on, say, things like the climber. Or not necessarily the climber, but like something that needs to rotate on a diagonal that also needs to be able to rotate on those two directions. So knowing all the mates is extremely important. Thank you for coming to office hours. I guess we're calling them office hours because I keep saying them, Vincent and Saeed. For anyone that's watching the video, thank you for making it this far. I think my food is about to get here, and I am extremely tired. So I think I'm actually gonna end it here. Do you want to
got pizza,
say any
Chad?
words to the to those watching it afterwards?
Yes. I will say that, kind of like I said, limits are a really good thing to go over, but unlike mates themselves that I would argue it's a bit harder to get involved in them just by messing around. Limits are something that if you just mess around with them a little bit, you'll become really good at them. So definitely look into that.
You got any comments, Saeed?
I would say that mates are really important along with limits as themselves too.
I'd like to
So,
thank you
yeah.
all. I just got a DoorDash notification, so I think this is my time. Uh, Thanks for watching.
Enjoy your pizza, Chad.
Oh, it's not pizza; it's
Enjoy it.
Japanese. I couldn't afford a pizza all by myself.
Ooh,
Japanese is still good.
Yeah,
hey,
it's good.
Japanese
like,
is actually kind of more
It's
expensive than
really
pizza,
good.
low key.